Hi friends, welcome to the Horn Splash Academy. Welcome to the first lecture in the lecture series of Signals and Systems. In this lecture, I want to explain the basic concepts of the signal and systems. This is very important subject for electronics and communication engineering students. In this lecture series, I am going to cover the entire syllabus of signals and systems which comes under JN2H Hyderabad. At first, let me introduce the entire syllabus. If you see the entire syllabus is broadly classified like this. In the first part, I am going to explain the analogy between the vectors and signal. That means, what is the meaning of signal? What is the meaning of vector? How signals are expressed in terms of vectors? Those points I want to cover in the part number 1. And in the second part, I'm going to explain the classifications of the signals and systems. If you see the classifications of signals, there are total 6 classifications of the signals, starting from even and odd signal. This is one classification. Periodic and non-periodic signal. This is another classification. Energy and power signal. Real and imaginary signals. Like this, we have total 6 classifications of the signals. Similarly, when it comes to the systems, there are total 7 classifications of the systems. One is linear and non-linear systems, time variant and time invariant systems, static and dynamic systems, causal and non-causal systems, stable and unstable systems. Like this, we have total 7 classifications of the signals systems. So these 6 classifications of the signals, 7 classifications of the systems, I'm going to cover in the second part. After that, I'm going to explain the concept of Fourier series and their properties. Why Fourier series is required? What is the purpose of using Fourier series? Those points I want to cover in point number 3. And after that, I'm going to cover the Dirichlet condition. After that, I want to introduce the Fourier transform and their properties. What is the purpose of using transform? Normally, if you see the systems domains, you will come across two types of domains. The first domain is time domain, second one is frequency domain. Some systems are represented in the time domain, some systems are represented in the frequency domain according to their flexibility. If you want to convert from one domain to this another domain, you need a proper technique. The technique is called a transform technique. There are 3 different types of transform techniques we are going to study in signals and system syllabus. The first transform technique is called the Fourier transform. Second transform technique is Laplace transform. Third transform technique is Z transform or G transform. That means in this entire syllabus, I am going to explain the Fourier transform and their properties, Laplace transform and their properties, Z transform and their properties. After that, I will explain the sampling theorem, cross correlation and autocorrelation. This is your entire syllabus of signals and systems. Now let me start with the definition of a signal. What is the meaning of signal? If you come across different textbooks, you will find many definitions of the signals. Out of all, I am going to explain very prominent definition of a signal. In order to define the signal, I want to take 3 important terms into consideration. The first term is time varying. That means the signal is not a constant one. The signal is always varying with the time. Second parameter or the second term is physical phenomenon. It is not a hurdle. Physically occurring one is a signal. And the third term is it has some information. The main intention of a signal is to carry some information. By clubbing all these three terms, now the signal is defined as it is a time varying physical phenomenon which is intended to carry some information is called the signal. If it comes to the examples of the signal, our voice is one best example of the signal. Electrical signals like current signal or voltage signal or power signal is another example of the signals. Heartbeat is another signal example. This is one prominent definition of a signal. I want to give another definition of signal is also like this. It is a function. The signal, it is a function, depends on independent variables. See this expression. This is one signal function which depends on three independent variables. What are those independent variables? X1 is one independent variable, X2 is another independent variable, X3 is another independent variable. If the function depends on multi number of variables or single number of variable, then it is called the signal. Based on this signal definition, I want to classify the signals into two categories. The first category is single variable signal. That means the signal function, if it depends on a single parameter or single variable, then it is called single variable signal. See the example. F is one function, signal function. It depends on only single variable called x. F of x is one signal function, depends on single variable. See the second example. G is another signal function. It depends on only single variable which is called t. That means g of t is another signal function, depends on single variable. There is one more classification of the signal. If the signal depends on multivariable or multi-parameters, then it is called multivariable signals. See the example. F is one signal function, depends on two variables. One is x1 and second is x2. Take the second example. G is another signal function, depends on three variables. One is t1, t2 and t3. This is one signal function. So these two signal functions are known as multivariable signals. F of x, g of t are known as single variable signals. Now let us discuss the system. What is the definition of a system? System is defined like this. It is a group of devices connected in a network to perform multiple operations on the signals. If you see the block diagram, this is a system. This is not a single device. This is a group of devices connected in a network. That is called the system. It has input, it has an output. In some systems, it has multiple inputs and it has multiple outputs. Normally, if you come to the traditional language of the systems, all the inputs are known as excitation signals. If you come across this word, excitation signal means you consider that is input signal. The system output, it is also known as responses of the system. Excitations of the signals is known as the input of the system. Response of the systems is known as the output of the system. Now let us take one example of the system. I have shown a pumping water. There is a motor. It has the motor and pipeline. This is all combined together forms a system. It is connected